Okay, guys, thank you all that you decided to stay and to listen to this lecture. I will try to be understandable because it is a very important stuff, because it is about algorithms. So in your last project with arrays, you wrote a lot of algorithms yourself. You did search, you found the biggest element in array and so on. And now we will learn a more complex level of algorithms, and it is bubble sort. What is bubble sort? It is a sorting algorithm. So imagine that you have an array with numbers, and it is unsorted, like it is a random array with random numbers. And your task is to sort elements in this array in the Assyrian order. So is it clear, yeah? Everything is simple. So for example, you have this array, 12, 45, 32, 5, 67, and it should be 5, 12, 32, 45, and so on. How we can achieve this? The easiest way, the most easy for understanding algorithm is bubble sort. I don't know why it is called bubble sort, to be honest. But I don't know why bubble.
Because it's like, yeah, if it takes like the smallest or the largest element and it changes it, it goes like further.
Yeah. But why bubble anyway?
Well, because if you look at it vertically, like.
That's interesting point, because I never looked vertically. I always thought like here, this is our array, horizontal one. Okay, so the point of this algorithm, let's look at this beautiful heap, how to start it. So attention please. So we compare elements, one element with another, which is near. Then we go to the next element and we compare them, and if it is less, we change them. And next, we move next. So we are going to the next element and next element and next element. And in the end of this iteration, we will have the highest element at the end. So it will be on the right position. So we change, we will change again, and 8 will be on the right position. So we have one element on the right position. And then we start again, enchant them again. So this is the logic of the bubble sort. So it will be a loop inside loop. The outer loop is the length of our array, because we need to perform these swaps n times. So we swipe elements till it is on its perfect place, and we do it again till the next element is on the perfect place, and again and again and again. And it is loop inside loop, because the inner loop swaps. The outer loop just start again. Do you have on this point some questions? How do you like this GIF?
Well, it looks very clear. Crystal clear.
Nice. Now we will go to the code. It is not very hard. So let's go next. This is a pseudocode, which I was trying to explain you. So we should repeat n times this thing. We traverse the array with a counter, and we compare one element and the next element after it. And if they are this element is less than this element, we swap them. And this way, the highest element goes at the end. And we repeat it n times, because first element, then next time, second element. So it's loop inside loop. N is array length, so we repeat it as many times as there are elements in the array. And outer loop should be this condition. This condition, when the loop stops working, is when j is less than n minus 1, because we are comparing aj element with aj plus 1. If we will leave n here, not n minus 1, then we will get out of boundaries exception, because j plus 1. because we will try to add 1 to the last index of the array. Do you understand? Okay, dobre. So yeah, make sure to avoid this exception and be careful with that. And now, how we will swap elements. So we have aj element and aj plus 1 element. We need to swap them like this. How we can do it? We need to create a temporary variable, and we are writing aj element in it. So I will explain, maybe draw. So we have like 6, 1, 7. We want, this is a j element. This is a j plus 1. We need to swap them. This now should be 1, and this now should be 6. How? How we are doing it? So we create temp variable, and this element goes in it. Now in temp variable we have 6. Now we can change this one because we stored its value in a temporary variable, so we now can change it. And we are changing it. So now this element is 1 and this element is 1, but we need now to make it 6. So we do like this, temp. Who has questions? Maybe someone has questions. Someone should have questions.
Well, I mean, personally, I already did a similar thing in my project when I was deleting an element from an array.
Yeah. So again, we need to swap this element places. We write 6 in temp. Now we can change it because we already don't need this value because it is here. We write here 1. Now this is 1 and this is 1. We need to write here 6. And after this, we will have 1, 6, and 7. So that is the point. Let's look on the code. So let's see. We have loop and another loop inside. This is outer loop. It goes n times till the 0 and till I minus n. So that means that this loop will be run n times. So if we are talking about loop inside loop, that means that inner loop is being run n times and it is controlled by outer loop. So this loop just repeats our processes. It doesn't perform logic, it just repeats processes. The logic is performed here. This is our main loop where we swap elements. So we start from the 0 and we go till n minus 1. n minus 1 because we will look j plus 1 and we don't want to get an error. So we are going our first iteration. We compare first element of array. We compare it with the second element of array. And if first element bigger than second, we swap them. Here is the swap. Next iteration, j equals 1. We compare second element of array with third element of array. If it is bigger, we swap. Then we compare second element of array as a third element of array with fourth element. And we do it till we are the one before last element. This is n minus 1 and the j plus 1, the last element. We compare it, and one element after this loop, after one iteration of this outer loop, when one time this loop is performed, we have one element which will be at the right position. And we need to do it again and again and again until all elements are on the right position. So, again, this little loop it moves one element to the right position, but we need to move all elements to the right position. That's why we have this outer loop. Let's see traces. So you will have this in your homework, so it's important to understand how elements are being swapped. So we have our initial array. We have outer loop iteration 1, and we are going to the inner loop. So we look at this element and at this element. If it were bigger than this, we would swap them, but they are not. So we are going to the second iteration. We look on this element and this element, and we definitely should swap them, so we swap them. Next, we look at this element, this, and this element, and we swap them. So it goes like this, and as you can see, we have this element on its place and this element on its place. And then we go outer loop, iteration 2, and we start again one by one comparing elements and move them. Maybe some questions?
I have questions to
Yeah.
the code.
Yeah.
From the previous slide.
Yeah.
Shouldn't I in the outer loop be 1 as the first value? No?
What do you mean, first
Like-
value?
Yeah, int I equals 0 we have in the declaration. Shouldn't it be equals to 1? No?
Why?
It's like too many iterations? No?
No,
Okay.
no. Too many if we had here equals.
Mhm.
So here we will have as many iterations as elements in the array because we start from 0.
Ah, yeah, okay.
Yeah, and we go till basically n minus 1 because n is, it is like strictly less.
Mhm.
Yeah?
Yes.
Yeah? Okay. Okay, so let's look again. Swap, 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 don't swap, and right position, and again. So as you can see, we are checking this last element, but it basically makes no sense because we already know that the last element is on the right position. And on the next iteration of outer loop, next element will be on the right position. So basically, it's kind of like stupid to compare them again, like you see here. That's why we can optimize the algorithm. How we can optimize the algorithm? So potential improvement. So here you can see the inner loop of a bubble sort, but something had changed in this algorithm. We have this minus e. So before we had just j less than n minus 1, now we have minus e. Why? Because the last element, we know for sure that it is on the right place, so we can skip it when we are comparing. So we have this minus I. How does it work? So we have elements. We swap them, swap, and this element is on the right position. On the first iteration, as we have minus 1 minus e is 0. So we look through all these elements. The second iteration will be minus 1, so we will not look at this element anymore because we know that it is on the right place. So we will compare this. We will not touch this element. Next, this element also on the right position. So it will be j minus 1 minus 2. So we will not look at this element. We will compare only this one. What do you think about it?
Elegant, I might.
Yeah,
We could have another optimization. This is like
yeah,
when nothing changed.
yeah.
We can check every time this boolean, so make it false. So if we do not check any, or we do not swap any element, we just make it true and get out of.
Yes, it's a really wise word because if we don't swap anything, that means that our array is already sorted, so we can just go out of the bubble sort. And yes, so I have it here. So after each outer loop iteration, the largest element is already in place. Yeah, and at some point we will sort all the elements, but our loop, it is very inefficient sorting because it is in quadrat because it is outer loop and inner loop, and inner loop, like if we have 10 elements, this sorting will be performed 100 times. It's a really inefficient algorithm, so we can try to improve it a little bit. We have this realization. Let's look. So here we have this inner loop optimization I was talking about, -I. So we will not check the last elements, which are already on the place. We can add this flag swapped, and here is the point. So we perform the first iteration of our loop, of our outer loop. We go to inner loop and swap elements, but imagine that we don't swap anything. That means that they're already sorted and we don't need to go to the second iteration of the outer loop. That's why if there is nothing to change, we will not make this flag true. And if it is not true, we break and we go out of bubble sort. That means that if we have sorted array, we go to the bubble sort. It is iteration 1 of the outer loop. We go all iterations of the inner loop and we don't change anything. Then there will be no second iteration of the outer loop because it is sorted, nothing changed. But if we swapped something, then it will be a second iteration of the outer loop and we will swap again. But maybe this time array will be sorted and there will be no third iteration. Questions? What don't you understand? Yes, it's true, and it is kind of difficult. I understand, and it's really hard to understand it from the first time, especially if you didn't have a lot of experience in programming and a lot of experience in algorithms. So it is really important for you to practice at home, to write bubble sort without ChatGPT, and try to write it, and maybe you will get some errors or it will not work, but it is great because the main point is to practice. Yeah. Yes. So here we are checking elements in the array. We start from 0 and we go forward. And here we swap them, compare, and so on. This loop is basically it does nothing. It just repeats this code, because when the inner loop is performed, we have only one element on the right position, only one element. That's why we need the outer loop to repeat it again to have second element in the right position. And inner loop always starts from 0 and compares element one by one.
We set it to true, so if it's swapped, we can break out of the loop.
So I understand the last one, but I mean, why false in the order and true in here?
That's why when
You can do it in the opposite way, like set true in the outer and to false in the inner. But it doesn't really matter as long as your if is checking correctly.
yes. So look, we perform this loop when swapped is true. If swap will become false, we break. Here we, at the start of the loop, we write swapped false because here it should become true. If it's here it will not become true, then we will leave our loop. And it will become true only if array is unsorted. If we swap some elements, because if we don't swap elements, this means that array is sorted, and we will not make swapped true, and it goes here. It looks like, oh, it is false, and we go out of these loops.
Does that affect the time complexity?
A little bit. Yeah, it's more optimized. Yeah, but I don't know. It is really bad complexity. This one, really bad complexity. So I'm not sure that it is really helpful. But it's good because, for example, imagine that you have sorted array, and bubble sort goes in the sorted array, and it just will not perform any operations because it will see that it is sorted due to this swapped. But imagine you have array from 1,000 elements, so you need to do all this operation 1,000 multiplied by 1,000, and imagine that it is sorted already. You don't need to do anything, but it anyway will work and work and work.
So what happens if like the first element is sorted, but the end is not? Is it not gonna break?
No, it's not gonna break because this inner loop, it goes through all elements. So it goes this, then this, then this, then this, then this, then this. And if we didn't swap even one time, it means that it is sorted. At least one time should be swapped. Okay. What else? Do you have some questions?
Could you explain the last piece of code? If it doesn't equal,
If swap is
if it's not swapped, then it's break. So could you explain what is this code for? What is the snippet of code for?
Yes, again. So look, if we don't swap elements, it means that array is already sorted. Because there was 0 swaps, that means that array is sorted. And if there was 0 swaps, then we don't change swap to true, it stays false. And here, if it is false, we break, and we don't compare elements anymore because everything is sorted. But if we swap at least one time, it means that it is not sorted. So we change it to true and start again. And next time, if we swap, we also change to true and start again, till we are not sure that all elements are sorted.
So just for us to understand when it's gonna end with checking whether it's sorted or not.
Yes, and we need to make swapped false here, because if we don't, if we make it maybe here, then we will change it to true, and we never set it to false, so loop will continue working. So at the beginning of every outer iteration, we need to change it to false, and then maybe it will become true, but maybe not. Okay, so guys, very important to practice at home. I can show you our class work. If we had time, what you had to do: generate array with random values, output it, sort using bubble sort, output again, and count the number of iterations and swaps. And improve algorithm. I showed you the code. It's like ready code. Try to do it at home, please, to yourself. It's really important to understand, because you have like new нейронные связи when you write code, and it will be easier for you in future. It's like the base.